Hello everyone, I'm Kritika Singh, a BTech CSC second year student. Along with my teammates Altaf Ansari and Hiteshi Jain, we worked on a project titled User Friendly System Call Interface for Enhanced Security. Now, before getting into the project, let me start with something real. Imagine you have downloaded a simple application, maybe cracked version of a paid tool or even something that looks completely harmless. You open it, everything feels normal. But in the background, it starts reading your files, checking your file directories, maybe even running command without your permission. And the worst part, you don't even realize that it's happening. This is not just a theory. This is exactly how lot of malware and unsafe applications work. And the reason they can do this is because of something called system call. Now, in simple terms, system call is the bridge between program and the operating system. They allow the program to read or write files, manage processes, access system level resources. So basically, system calls are powerful. In fact, very powerful. But here is the problem. If the power is not controlled, it becomes dangerous. Unrestricted system call can lead to unauthorized data access, command injection attacks, privilege escalations, and in the worst cases, even full system compromise. So the real issue is not system call themselves. It is who is allowed to use them and how. That is exactly what we wanted to see. Our objective was simple but important. Allow the user to perform system level operations but in a safe, controlled, and monitored environment. And that is where our solution comes. We developed Cyberport. Instead of giving user direct access to the system, we created a web-based interface that acts like a control layer. Think of it like this. You still have the access to system operation, but you need to be authenticated. You can only perform the allowed action, and every single operation is tracked. So instead of blocking power, we are controlling it intelligently. And this is important because in real world system, you can't remove functionality for security. You have to design system where security and usability both go together. And that is exactly what CyberCourse tries to do. Once you actually see how this works in real time, it becomes much clearer how everything is connected.
So hello everyone, my name is Altaf Ansari, bearing registration number 1240456, and let's see how our system actually works in practice. So this is the login interface. Once we are authenticated, they are redirected into the main dashboard. And now on this dashboard, you can see a list of available items, that is reading file, writing into the file, creating a new process, and so on. Let's try one of these and see how it works. Let's select the list directory option and you can see the output is being displayed instantly. Now from the outside this looks very simple, just a click and you get the result. But internally there is a lot of things happening inside and it is safe. Every time when you run the process, the backend is being executed and each and every step is being validated and checked against the predefined whitelist. Now if the request is valid, it is allowed to execute. This is where our core area comes in. We don't allow the unauthorized user to access. So we have used here the JavaScript wrapper layer that acts as a filter between the user and the operating system. So even if someone tries to send a malicious command like accessing the restricted files using commands, so that is being prohibited by our system. So what are the more security layer we have added into this? That is the JWT authentication to manage the session layer, bcrypt, and also the role based access system, that is the user and the admin who can access it using their roles and get into the system. So security is not just one feature, it is built into a different layer of our system. So the another important part is the login page. Every single system is called and recorded, not just once but in the places. A continuous logging file is being saved. Each operation we store in our local MongoDB of the VS Code, so we haven't used the actual MongoDB. So overall what looks like a simple interface is actually a fully controlled and secured monitor system underneath. And when we combine all these layers, you just don't execute the system calls, you execute them safely, and that's it.
I'm Hiteshi and now I will present the outcomes and conclusion of our project. As Altaf just demonstrated, Every action in cybercode passes through authentication, validation, and logging. But what does that actually mean in terms of real results? During our testing, we observed that the system successfully blocked all unauthorized operation attempts, every single one of them. No command outside the predefined allowed list was ever executed. This directly validates the core security objective of our project. We also measured performance. The average execution time for system calls like listr and readfile remained under 200 milliseconds, even when multiple users were active simultaneously. This confirms that our security layers do not come at the cost of performance. On the logging side, every single operation was recorded with full details, including the username, the operation type, the timestamp, and whether it succeeded or failed. This means that if anything suspicious ever occurs, there is a complete, tamper evident audit trail to trace it back. Now, what makes CyberCode different from existing tools like SecCom or AppArmor? Those are powerful, but they operate at kernel level and require deep system administration knowledge to configure. Cybercode, on the other hand, brings that same level of a control to a clean, accessible interface that even a non technical user can operate without compromising security. We do acknowledge that the current version operates in a sandbox environment and supports a defined set of operations. In future, we aim to expand the system call library and explore the integration of machine learning based anomaly detection so the system can proactively flag suspicious behavior before it causes harm. The key takeaway is simple. People often assume that if a system is very secure, it must be complicated to use. And if it is easy to use, it cannot be truly secure. Cybercode breaks that assumption. You do not have to sacrifice ease of use to have strong security, and our project is the proof of that. Cybercode ensures that every action is visible, every action is accountable, and system level power can no longer be misused silently. Thank you.